Last class, we talked about putting the table on the graphing grid, and then we talked about y-intercept, and also I introduced what slope is. So I mentioned before the slope is a rate of change. So we're going to define rate of change first. So rate of change, which is also slope, we can define it as a ratio that shows how one variable changes with respect to another. So on a linear graph, this is called the slope of a line. Slope is written as a ratio of the vertical change. Vertical change is rise to the horizontal change, which is run, between any 2 points on a line. This remains constant for any 2 points on the same line. Slope is written as a fraction in simplest form, or you could say reduced form. Variable we usually use for slope is m. So remember the equations that we have seen had slope, which is m, and then multiplied by x and added by y-intercept. So this is slope and b is y-intercept. And we also talked about this briefly. So sometimes your graph looks like this. Sometimes, so your right side is pointing up. Sometimes it's pointing up like this. And then sometimes it's pointing down. Right side, your right side is pointing down like this. Sometimes it's a horizontal line. Sometimes it's vertical line. So when your right side is pointing up like this, then your slope m is positive. M is greater than 0. So positive slope. And when your right side is pointing down like this, then your slope is less than 0 and it's negative. And when you have horizontal line, then your slope is 0 and your graph is a vertical line like this, then your slope is undefined. And I'm going to try to circle the right side. So right side is pointing up when you have positive slope. It is pointing down when you have negative slope. Then we're going move on. Now you're gonna try to find the slope of a graph. So we talked about finding the ratio between y change over x change. You can put this triangle means the change, and also you could say y change is rise, x change is run. So let's look at 2 points. So you can pick any 2 points, but it is always more convenient if you pick the integer ordered pairs so that you can work with just the integers. It is a lot easier to calculate the slope. So between these two, let's do rise over run. So rise 1, 2, 3, 4. Then I'm gonna change the color. Oop. Yeah, I'm gonna change the color. Then do run over 1, 2, 3, 4, 5. So that's my slope. And then I'm gonna do the next one. You can try your own first and then check your answer with mine. So now I'm doing from here to there. So doing 1, 2, 3, 4, 5, 6. 6 over. I'm gonna change the color. So it's gonna be 1, 2, 3. This time it's 2. And now I'm doing from here to there. So rise would be, I'm going down by 2. So I need to do -2. And then over, I'm gonna change the color again. Doing 1, 2, 3, 4, 5, 6. So it becomes -1/3. Now I'm gonna do these 2 points. So I'm gonna do rise first from here to there. I'm going down 1, 2, 3, 4, 5, 6, 7. So -7. If you go down, you have to use negative number. And then now I'm gonna count how much. I'm gonna change to the right. So 1, 2, 3, 4. So it's +4. So your slope is -7/4. Then we are gonna move on. So now you have this vertical line. So vertical line has only, when you look at it, it only constantly has the same x values. So that's the -3, and your x value is -3 there, -3, -3, -3. So wherever whatever point you're picking, it's always your x value is -3. So this time your slope is not defined. So my slope is undefined. And then let's look at your the next problem, number 6. Now you have the regular graph again. You have 2 points. Rise first. So from here to there, I'm doing 1, 2, 3, 4. Going up by 4 over. Now I'm gonna count how much I'm going to the right side. So I'm doing using red. So, well, it moved a little bit. Let me fix this. I guess I have to stick with the same color pencil, otherwise it's gonna get messing up with me. So I'm going to I'm gonna stick with just blue pen. So from here to, or red pen, from here to there, going up 1, 2, 3, 4, 4, and then over. Now I'm counting 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 1/2. Number 7, from here to there, I'm going down 1, 2, 3, over 1, 2, 3, 4, 4. And this one from here to there, 1, 2, 3, 4, 4 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have to simplify it. 4 and 10 both are even numbers, so go 2 or 5. So do it on your own and then just check your answer. From here to there, I'm going down 1, 2, 3, 4. And then from there, I'm going to the right side by 1. So this is -4. Now I have a horizontal line. So when you look at it, whichever point you pick, they always have constantly y value equal to 1, 2, 3, 4, 4. So this graph only has y-intercept 4, but doesn't have any slope. So this case, your slope is 0. So your graph starts with y equals, then slope is 0. If it starts with x equals, like number 5, then it's undefined. Now let's go to number 11, a regular linear graph. From here to there, it's to rise over run again. So I'm rising 1, 2, 3, 4, 5 over 1, 2, 3. Now, see, I went to the left side. When you go to the left side, from here to left side, it's -3. So it is -5 over 3. Now I'm looking at these 2 points. From here to there, let's count how many I'm rising. 1, 2, 3, 4, 5, 6. 6 over. Now from there, 1, 2, 3, 4, 4. So it is 3 over 2. The number 13, from here to there, let's count how many we're rising. 1, 2, 3, 4, 5, 6, 7. 7 over 1, 2, 3, 4, 5, 6, 7. So it is 1. the last one, from here to there, we are going down by 1. So rise -1. Then from there, 1, 2, 3, 4, 5. We went by 5. So it becomes -1/5. Now, once you're done with this note, you can go ahead with your homework on formative.